In this video, we will discuss about Palo Alto Firewall Architecture. Palo Alto Firewall Architecture is totally different than other next generation firewalls in the market. They are using SP3 architecture. S means single, P means pass, another P means parallel, and the last P is processing. So they are using SP3 architecture. In shortcut they call them SP3. And this SP3 setup enable high throughput, low latency network. Now keep in mind this SP3 is divided in two parts: single pass software and parallel processing hardware. But before going to that one, let's discuss other next generation firewalls. Other next generation firewall, when the traffic coming from the inside and going to outside, and suppose there is security profile enabled, so it will go to URL filtering, suppose it take 2 seconds, then it will go to antivirus 2 seconds, then it will go to proxy 2 seconds, then DLP 2 seconds. So this way it will go through all these security profile IPS as well. So it will take more time to process the packet because it will go one by one through all these. However, in the case of Palo Alto, which they call them SP3, it will not do such things. Rather than to take 2 seconds to URL filtering, they will do all the things at once. You can see this arrow is going all the way, single pass software. So we have a policy engine, we have application ID, user ID, content ID, networking. All these it will go through once. So rather than to take 2 seconds, 2 seconds, 2 seconds, 2 seconds, 2 seconds, and 2 seconds, rather like other next generation firewall, it will take only 2 seconds for all the stuff at once. That's why it's called single pass. It will go a single shot, and maybe I written here as well. And it will perform this operation once per packet. And one shot it will do. And this is stream based. And it will do all these things at once, such as networking, user identification, policy lookup, traffic classification, application identity, decoding, signature matching for detecting threads and malicious contents. Process of the packet in one go. It will do all the thing at one go and single pass. To do all the stuff, so the other firewall will take time to process by every engine, and they will do all the stuff at once. We will discuss this further, but just understand single pass. All the stuff it will do at once. Second part of this one is parallel processing hardware. They have a parallel processing hardware as well. And this hardware is divided in two parts: control plane and data plane. Control plane we also call them management plane, the management traffic. And data plane we have networking, further security and content. And management only management. So it's further divided. This one device, basically outside is one device, but inside they have a separate. It's like you can consider them virtually. It's like a VLAN, separate VLAN for separate purpose, another VLAN for separate purpose. One device for separate purpose, they have their own hard drive, they have their own CPU, they have their own memory and everything, which is called management plane. And they have a data plane separate. So two things are running separately. Why? We will discuss this as well. So in case if management is failed, even in the firewall, if you go there and go to system resources, you're gonna find two things: management CPU and data CPU. Why two CPU is showing? Because they have a separate plane. So now I access this firewall through management. So if management CPU reach to 100%, so I will not access this firewall. I will not do any reporting or any monitoring. However, the data will go and it will work. Because management is using separate CPU, separate hard drive, separate everything, and data plane has separate. Either if the data plane reach to 100%, still I can access the device. If something goes wrong with the data plane, I can still access the firewall because management plane is totally different. So it's divided in two parts, and this division is called parallel processing hardware. Hardware level is divided. So we have single pass software base, which will go through all these in one shot rather than the other firewall to do step by step. So it's like a Superman to do everything at once, and this way it will provide you more throughput. There will be no slowness. And do all the thing at once. So 2 seconds take this one, 2 seconds suppose. They will do all the thing in 2 seconds. So this is called single pass software. And it will do all the stuff which I told you. And scan packet once in stream-based fashion to avoid latency and throughput. However, I told you other firewall not do such things. It will increase the overhead of CPU and other stuff. Now coming to the second part of this is SP3 architecture is parallel processing hardware. So they have a separate hardware for dedicated data plane and management plane. So by separating up data plane and control plane, ensure a heavy utilization of either plane will not impact on the performance of other plane. So they have a separate plane for each, which I show you here as well, is showing in the firewall as well. So let's discuss those two planes. So we have a control plane and data plane. So they split these two planes, data plane and control plane. So if one plane has some issue, the other will not impact. Now control plane, as I say, is called them management plane as well. And they have their own dedicated control plane processor. And this processor is responsible for tasks such as management, configuration of Palo Alto firewall, and also for logging and reporting purpose. So this management plane, which I show you here, so you can access the firewall graphically through CLI or whatever the reason, through API or any reason, and also to generate the report, etc. And all these things. So for that purpose, you can use this control plane. Either we call them management plane. For logging purpose, the logs which they are sending and the monitoring, etc. So all these things is through management plane. So they have their own dual CPU and dedicated RAM and dedicated hard drive. So they have totally different everything. This is called control plane. Data plane is high-end model and they have their own CPU, high-speed buses and CPU, which is used for data plane. The traffic, the user traffic which is forwarding. You get the idea? So these are the two plane. And they have type of processor, security matching processor. So this is a dedicated processor to perform vulnerability and virus detection task. Signature match processor. So this is a special type of processor for this activity. So it means we have a control plane and data plane. The Palo Alto firewall is divided further, even though outside is one firewall, but inside is divided further. Then every plane has their own different processor for different purpose. Like the processor security matching processor, the job of this processor to perform vulnerability and virus detection. Security processor, this is a dedicated process that perform hardware acceleration and handle security tasks such as SSL encryption and decryption, IPsec encryption and decryption, and other tasks. Look at now, they have separate processor. And network processor, So this is the dedicated processor responsible for routing, net, quality of service, now route lookup, make lookup, and all those activity related to network. So they have their own processor. So if we come here, so we have a control plane. Control plane also call them management plane. So in management plane, they have their own CPU, they have their own RAM, they have their own SSD. So this is a management interface and console. So through these two we can access, and even by other means. So the main purpose of control plane is configuration, logging, and reporting. These three the main, and they have a separate CPU and RAM and hard drive. Then we have a data plane. Data plane further divided in three categories. We have signature matching, security processing, and network processing, which I show you here as well. I believe somewhere I show you. Here is networking, security, and contents. So if we go further, okay, so they have signature matching components, which I told you, such as virus, spyware, and SSN, and for all these activity they will use signature matching. Security processing, I told you, user ID, URL matching, so they have their own job, and network for routing, etc. And these are the data interfaces. So these are the two plane. Let me explain you by another way. So we have a control plane and we have a data plane. Control plane called the management plane, okay, and they have their own RAM and hard drive, dual core CPU, which I told you, and this is totally separate, and their job is separate, and the main purpose is logging and all those management activities. While data plane is further, they have a signature matching processor, which I told you, multi-core security processor, and network processor. And every network processor has their own, again, CPUs for different activities. Again, CPU inside a CPU, they have different CPUs for different activities. And that can be changed in every Palo Alto firewall model, but this just one model example. You get the idea? So I hope so at least you get the idea that what is a single pass parallel processing SP3 architecture. So SP3 architecture is in two categories: single pass software and parallel processing hardware. Single pass to pass all the data at once using all the stuff: policy engine, app ID, user ID, content ID, networking, to do everything at once and pass them and just do the job. While the parallel processing hardware is divided in two plane: control plane and data plane. Data plane has their own job and control plane has their own job, which we discuss one by one. So this is a quick overview of Palo Alto firewall architecture.